Hi, I am Aparna Haryani and today I am going to present my project on handwritten digit recognition using k-nearest neighbor and histogram of oriented gradients. So, the question is, why do we need handwritten recognition? These days, digital revolution is taking place, and with the need of digitization, we need handwritten recognition. For example, there are forms in handwritten data and you want to convert it into a digital copy. Yeah, there is an option of scanning it, but you cannot always go back and search the information in the form. So, if you want to search the information in the form, you need a digital version of the handwritten data or the OCR or handwritten data converted into a digital copy. So, for this reason, we need handwritten recognition. Also, machine learning is in great advancement these days and it's taking over almost all the applications. It, there is in very near future there would be a time where machines would be checking or correcting our papers. So to correct the papers, efficient handwritten recognition is very important. There have been various studies and approaches made for the betterment of accuracy and efficiency of handwritten recognition. For efficient handwritten recognition, feature extraction and classification play a major role. So, one of the examples where we would need handwritten digit recognition is in banks where we write checks. It has our account numbers and also the amount which is to be deposited. So, to deposit the correct amount into the correct account number, we need the digits to be recognized very correctly. There would be an age where, like ATM machines, where we deposit bills, we would be able to deposit checks and we wouldn't need any banker to make manual deposit to our account of the given amount. We would just deposit our check in the machine and the machine would do it for us. Hence, there would be no need for us to go in the banking hours and deposit the check. So this is the need for handwritten recognition. And how do we recognize handwritten data efficiently and accurately is with the use of classification algorithms and feature extraction methods. The classification algorithm I am going to use for my implementation is k-nearest neighbor and the feature extraction method is histogram of oriented gradients. So there have been many existing approaches using k-nearest neighbor, support vector machines, and histogram of oriented gradients. So let's start with k-nearest neighbor. What is k-nearest neighbor? It is the most simplest classifier. The figure here shows the k-nearest neighbors working. Supposedly, the green star here shown here is an unknown class, and there is a trained data of red and blue classes. So we have to decide what what class does green star belong to. For that, we decide a integer number for k, and according to that, we take maximum votes and decide whether the green star belongs to red class or the blue class. Let's see. So when k is equal to 3, the votes counted are within this circle. Hence, the maximum vote is red, and when k is equal to 3, the green star belongs to red class. When k is equal to 6, the situation is flipped, and we see that there are more blue boxes compared to the red ones. Hence, the unknown class belongs to blue. This is how k-nearest neighbor works. Support vector machines work on a similar basis where there is a plane and there are many points, but they are split into different points depending on the classes. So there is a area of plane where it's just red classes, and where there is an area of plane where there is just blue classes. So when there is an unknown point, if it's in this red section, it belongs to the red class. If it is in the blue section, it belongs to the blue class. This is how support vector machine works. Histogram of oriented gradients is a feature extracted algorithm and most widely used. This is one of the examples of how it works. So if supposedly input digits were given in this format, so in this image format, it would recognize all the digits in the this format, and hence the feature of 0 would be there would be a smaller o and all the edges and everything would be recognized. So my program algorithm is as follows. Initially, I read test image and the training image from the command line and then convert them into grayscale. And after that, for the training purposes, I'll convert the image into arrays of images and labels, and then I would extract features using HOG and then classify and train the digits using k nearest neighbor. Hence, there would be different classes like the red and blue boxes we saw above for each of the digits. Hence, there would be 10 different classes in our training data. Now, for recognition, we read the image, convert it into grayscale, and find the contours of the image. And then we convert pick and each image from each digit from the image, and we process each of the digit with it. So with the help of contouring in OpenCV, I have done this. Then there are morphological operations performed on it like opening and closing to smooth the image edges, and with the help of thresholding, the features are extracted using thresholding and provided it to HOG. Then it is predicted using training data. So let's see a demonstration of it. This is the command I sent. This is my file name. This is the training image and this is the test image. So let's start with test image 1. So after this is processed, we will have an overlay image and final image and the actual image. We'll compare them and just see how the results come to be. So this was our training file. This was our test image, and these are the predicted digits. This is going to be our final image, where we can see it has predicted most of it correctly except for the 6 and the 8. It is predicted most of it correctly, giving us an efficiency of approximately 85%. Let's see one more image. This is a larger image, hence it's taking a longer time. I have to work on this, improving the efficiency, making the runtime as low as possible. So this was the test image, and we will wait for the results. Handwritten recognition also depends on the strokes of the training data and the strokes of the test data. So it completely depends on how much training data you can provide. The more the training data, the better the recognition. In this case, I am using a total of 5,000 digits of data, which gives me 500 digits per data. And yep, we are done. So this is the overlay image and this is the final image. Here we see it has mispredicted most of them and the accuracy is not very good because the handwriting is not very good and the training data provided is not so much. So there are MNIST data sets where you can provide up to 5,000 digits of data set per digit. That gives you 50,000 data sets. I have just provided 10% of it. So these digits are recognized as confused. This was supposed to be a 5 and it's confused between a 3 or 5. This was supposed to be a 5, it's confused between 5, 8 and 2. The efficiency of recognizing 1 is not so good. 2 is always predicted correctly, 0 is always predicted correctly. So I am working on it on improving the accuracy. This is a performance evaluation digit wise. So I use the MNIST test data set for each digit and it had 1,000 test cases and these are the data for it. So I found out that 0 had the most best accuracy whereas 1 had the worst accuracy, giving me a average accuracy of somewhere around 75%. These were various test images which I tested. I tested more than this, but yeah, this is the short version of the data, and the best efficiency I got was 83.33% and the worst was 47.50%, where giving an average of somewhere around 70% again. So this is a similar, just the accuracy comparison of all the digits, where you can see 0 is the most correctly predicted digit, 2 is better, and 1 is the worst. The rest are average. This is the percentage accuracy of all the test images which I tested, and yep, we can see that the average was around 70. The accuracy for existing approaches vary from 70 to 96%. The existing approaches include SVM, HOG, and some other feature extraction methods, KNN with some other feature extraction methods. My approach has an average accuracy of 70% for any type of image. I have not made any assumptions as of yet. So I can give any size of image, any size in dimensions, any size in the file size. It will do it. Yeah, it's gonna take a while, but it will predict it. So the accuracy can be improved using larger training data sets, as I mentioned before, or by using a combination of 2 or more classifiers, like a combination of KNN and SVM. I feel can be used for better prediction, as KNN is spread out throughout the space and SVM divides the space. It would be easier to judge what is the class of the unknown data which we have to predict. Hence, I conclude that the best case accuracy of my project is 83% and the worst case was 47%. The average accuracy I found was somewhere around 70%. So